today we again continue case 2. That means case 2, the object projected from the ground. Like this object is projected from the ground. In this case, the object is projected with initial velocity u. This is the initial velocity. Let's say this is the initial velocity u, and we have the vertical and the horizontal velocities. Let me show you one simulation. Then we start to drive the equation. Here is a simple simulation. Look, we have angle this. Now we have initial angle at 80 degree. We can also make it 60. We can make it less than 60, 45 like this, and we can project. Look, you see, at 60, at for example at 60, look the projection how it look like. Okay, and we can see the velocity components, and look, you see, such kind of projection we call it the horizontal projection from the ground, okay, with an angle theta. Okay, now let's see this from the ground. We have an object, and this object move from, let's say, from O. This is, let's say, O to point A. We have, okay, then from point A to point C. What we have, the characteristics of the path of the projectile without air resistance. This already, when we talk about projectile motion, we have to neglect air resistance. The trajectory is always parabola. That means that this motion is parabola. Okay. The diagram is symmetric about point A. At point A, symmetric. See, O is the point of projection. This O is the point of projection. B is the point of impact. The point of impact, we call it this B, this side. And the length OB is the range. From this point to this point, from O to B, O to B is the range, okay? And also sometimes written as a displacement S, or displacement across the horizontal during problem solving, okay? The time to move from point O to the highest point A, look, from this point to point A, okay, the time E to the highest point A is equal to the time for the object to move from the highest point to B. From O to B, the time let me say O A is equal to time across A to B, okay? And let us see, this is at point A again. At point A we have the maximum height, okay, H maximum, okay. At point A again, our final velocity across the y is equal to 0. Don't forget. Let's see the characteristics, the horizontal and the vertical. Please note down this one. Always the initial velocity across the horizontal is calculated by V0 times cos theta. At the highest point, at point A here, the horizontal Vx, the horizontal component of the velocity Vx is equal to the final, the initial is equal to the final across the x. That means the velocity across the horizontal is constant. Here it's constant. That means the acceleration across x is equal to 0. Again, the horizontal displacement, we have sx, or we can say sometimes this from this point to this point, we can say r, or the range. For the vertical, we have the initial velocity and the final velocity. The initial velocity is say v across the y is equal to v times sine sine theta. U means the initial velocity that we already have at this point, and theta means the angle is theta. Okay, is theta, the angle. Alright, at the highest point, please point down this. At the highest point is at point A. The V final across the y, the V final across the y is there, we already said. Okay, the initial velocity is different from 0. Okay, don't forget. This initial velocity calculated by the u naught times sine theta. Theta is angle theta. Okay, the vertical displacement is 0. Why? Look, the object is projected from the ground to, again, back to, from O to P, point B. That means the displacement is the vertical displacement goes up and then down. That means it becomes the displacement across the y is equal to 0, because displacement is a vector physical quantity. Half goes half upward, the displacement across the y. Then when it's down, again negative s across the y. When we add this displacement, its value is 0. Now we are going to derive the equations. That means to derive the equation, we need this kinematics equation. Okay, please note down, and we convert this one to projectile motion. Okay, all right, let's see. All right, for the vertical projection, or for the vertical, we have let's say the displacement is equal to the initial times t plus 1 over 2 a t squared. Now we convert this into for the vertical. That means for the vertical we have y is equal to v naught across the y times t plus 1 over 2 g, we have negative g, t squared. Then t, which time we are finding for this object projected from this to this. Okay, this point O, this point A, this point B. The time is xy is equal to v naught times v naught y times t across a b. Okay, we're going to find the total time of flight. Okay, t o b minus 1 over 2 g times t square of o b. Previously we said that, look at this sentence, okay, please attention. The vertical displacement is 0 when it reaches at this point. The vertical, because it goes up and then down, then its displacement is 0 at this point. We are finding the time O to B, okay, in our case. Now let's change this one. That means here vertical displacement means we have the y, okay. Y at this point is what? We said 0, okay. Then 0 is equal to v naught y means there is angle theta, okay. Note that here v naught y is equal to v naught times sine theta, and v naught across the x means v naught times cos theta. Note down this one, okay, very important, because we have angle, okay, angle theta. That is why we use for each sine and for the horizontal cos. Now we have v naught sine theta times time of OB minus 1 over 2 g t square of OB, okay. I think it's clear why at this point y is equal to 0, okay. Now take one of them toward the left. This already 0. We have what's left? 1 over b naught sine theta minus b naught sine theta TOB is equal to minus 1 over 2 dt square. OB at the time of the total flight, okay. We are finding the total time. So negative by negative, okay, positive, okay. And TOB on to away by on to away v naught sine theta is equal to, let's select 1 over 2 v t o b. This implies the time from O to B is equal to twice of sine, v naught sine theta twice over g. This is the time of the total time of flight, okay. We already calculated from the time of flight from O to B. At point B, the vertical displacement when this object line projected and arrived from point O to A, then B, its displacement is 0. So the time of flight is calculated by v naught times sine theta over g. Good. Now we are going to derive the maximum y maximum, or the maximum height. We are going to derive the maximum height, h maximum or y maximum. Okay, y maximum. Assume here we have h maximum. Here we at point A, we have, at this point we have y maximum, or we can say h maximum. At this point, its final velocity across the y is equal to 0. Okay, it means our assumption, we know that v final across the y is equal to 0 at h maximum. At this point 0, then e again return down, okay, to point B, okay, after its final velocity across the y, 0. We know that in kinematics v final square is equal to v initial square plus 2as. This is kinematics. Let us convert it to in our case. That means v final at the maximum is already 0. That means we have 0. Okay, v naught across this one we can write it vy. Okay, displacement across the y. Okay, now let me clear it, okay, because it may confuse you. No problem. Let me okay. First, let's convert to. Sorry for the delay. This one is v final. V final is equal to this kinematics. In our case, v final substituted by v final across the y. Okay, square is equal to v naught square across the y plus 2 times g minus g, acceleration substituted by minus g, and s across the y. That means y maximum, because we are on the vertical projection. Okay, on the vertical projection. Now v final y at this maximum is already there, is equal to v naught y means v naught times sine theta the whole square, because here v naught y means v naught times sine theta. Okay, time minus 2 g y maximum, or h maximum, we can say is as h maximum. Now take one of them toward the left, then let's take minus this v naught square sine square theta is equal to v naught square sine square theta, okay, is equal to this one minus, because minus 2 g y max, negative by negative, positive, then over 2g divided both sides. That means this implies y maximum is equal to h maximum, which is equal to v naught square sine square theta over 2g. This is the maximum height that we can calculate at point A. Good. If you have any question, please write on the comment section. I will reply to you. And repeatedly look the video. Okay? Good. Alright, what about the vertical final velocity? The vertical final velocity. V final across the y. First, let's start from kinematics. V final is equal to V initial plus A times T. This is kinematics. We convert it to our vertical projectile motion. Okay, just V final, we have V final across the y is equal to V naught across the y plus acceleration, we have negative g times t. Then V final across the y is equal to V naught across the y means V naught sine theta minus g t. This is the final velocity across the y. For example, at this point we have vertical and the horizontal. Here we have V final. Again at this point we have V final across the y. This is V final across the x. So we calculate with this formula. Okay, this the maximum height, this the total time of flight. Don't forget. Okay, total time of flight. All right, let's continue. Now let's see that these are the vertical projection. What about the horizontal? For the horizontal, we have acceleration across the x, which is 0. Let's start from the final velocity across the x. Okay, how can we derive this equation? Let's start from v final is equal to v initial plus acceleration times time. In our case, v final across the x, okay, is equal to v naught across the x plus acceleration across the x times t. But acceleration across the x is 0 because we already talked about that here at the beginning. Ax is equal to 0. Okay, don't forget this important point. Okay, now very simplified. V final across the x is equal to v naught x means v naught times cos theta plus ax means 0. That means 0 times 0 plus 0 already 0. That means we have only this v final across the x is v naught times cos theta.
Welcome online physics and programming lesson. Give us comments for the improvements. Thank you.
What about the displacement? Across the x-axis or the horizontal. That means the displacement in kinematics is calculated by the displacement will be naught t plus 1 over 2 a t square. Okay, now in our case we have what the displacement we have, let me say s across x will be equal to b naught t means b naught across x times t plus 1 over 2 a across the x times t squared. We simplifies displacement across the x will equal to v naught x means v naught sine v naught times cos theta times t, okay, plus 1 over 2 times ax. Ax means ax is equal to 0. We already defined around across the x. This is already 0. Okay. Now 0 times t squared. This implies the displacement across the x is equal to b naught cos theta times time, or this can be written as simply x is equal to b naught cos theta times t. You can also write in this way because for the projection starting from this point to this point we have the horizontal distance r, or which is equal to, you can say x, okay, because it's on the horizontal. Okay, from point O A to point B at this point, so the horizontal range. Okay, so can we calculate this x at any instant time? Okay, for example, at this point we have x, at this point we have x. Okay, but at any instant time t, at this point we can calculate the horizontal displacement x by this formula. How can we calculate the total distance of the range? The total displacement, more the horizontal can be calculated by, or the range, we call it the range. Okay, this is the range. How do you calculate the range here? This from point O to point B, from point O to point B. So we already calculated that x, the horizontal distance, will be naught times cos theta times t. But in our case, from point O to B, from this point to point B, we have the total what? We use the total time of flight from TOB and this component. Okay, that means the total can be calculated by b naught cos theta, b naught times cos theta times time from O to B, from this point to this point, or look, from this point to this point. That means it gives our range, the total. So we have to use the total time, TOB. Okay, TOB we already calculated here. Look, t across OB here. We already calculated because we have this. Now let us substitute, which is equal to b naught times cos theta times 2 iso b naught sin theta 2 iso b naught sin theta over, look, we substitute this value, okay, over g, okay. I will repeat again. Here, at this, from this point to this point, we can find the value of the displacement x by using x is equal to the horizontal displacement equal to b naught times cos theta times t. Is at any instant time, okay. But to calculate the total as but for the horizontal motion, we have r from O to P is the range, okay, the total displacement. But if you are asked at this point, you have to use this formula, okay, at any point here or here, at any instant time. But if you are required R, the total, as for the horizontal, you have to use this equation, okay, and we have to use the time. We are not using this time, okay, just the total time that the whole trajectory that the object starts and arrive at point B, okay. We use the total time of flight, okay. That means the total time of flight we already calculate here. Total time of flight I already wrote. All right, now this can be written as v naught square twice of v naught square, or we can write like as it's, okay. V naught square times twice of cos theta sin theta over g acceleration. Now we have this question, but in your mathematics, sin 2 theta is equal to twice of cos theta sin theta. That means in your mathematics, so we can substitute v naught square times sin, this part is substituted by 2 sin 2 theta, okay, sin 2 theta over g, which is the value for the total horizontal distance, okay. All right, good. Now let's see the net velocity. The net velocity at any instant time t. That means we have the vertical and the horizontal velocities. The net is simply the net velocity is calculated by the square root of the final velocity across the x square plus the final velocity across the y square. Okay, this is the net velocity because if here let us consider we have at this point we have v final across the x, for the vertical v final across the y. Already it's matched with initial velocity u, okay. That means we have net velocity At this point, we have the net velocity. Okay, this is the initial velocity, that is v naught. But we have at this point is we have v naught. Alright, okay. So the net velocity, let's substitute. That means v net is equal to the square root of the final velocity across the x. Look, we already calculated here the final velocity across the x is the final across the x is equal to v naught times cos theta. We already calculated here v naught times cos theta the whole square plus the final velocity across the y. We already calculated here, okay, v naught sine theta minus vt. V naught sine theta minus g times t, the whole square. Okay, this is the net velocity. Okay, at any point, at any instant time, okay, t. Okay? Don't forget. Okay, let us see this example. You kick a soccer ball, giving it with a velocity of 22 meters per second at an angle of 63 degrees above the horizontal. A, what is the maximum height that the ball reached? That means, look, let me draw here. Okay, the soccer ball kicked like this with initial velocity v naught is 22 meters per second, and this ball has vertical and horizontal v final across the x, v final across the y. Okay, and it takes and arrive around here. Okay, A, what is the maximum height that the ball reach? At this point, let us say this is the maximum height. So you have given initial velocity, you know, is equal to 22 meters per second, theta 63 degree, and let's take g is equal to 9.8 meters per second square. You are required A, what is the maximum H maximum, that means the maximum height of the ball. H maximum is equal to how much? Solution. H maximum, we already calculate the formula. The maximum H maximum is calculated by v naught square sine 2 theta sine square over 2g. You can write here H maximum is equal to, alright, before going to calculate this part, let's find v naught y is equal to v naught sine theta equal to v naught 22 meters per second times sine 63 degree, which is equal to 19.6 meters per second. You can use your calculator for the exam, no problem. V naught across the x is v naught times cos theta. It means we can use v naught 22 meter per second times cos 63 degree. This again around 10 meter per second. Okay. Now the x maximum means 90.6 meter per second, the whole square, because we already have this, we already calculated here. Okay, over the whole square. Okay, over 2 times 9.8 meter per second square is equal to 19.6 meter. Okay, check it with your own calculator. This is the maximum height that is called for no. All right, let's do the second. All right, B, you are required. What is the total time that the ball is in the air for? You are required B. You are required the total time of flight. The total time of flight is equal to how much? Solution. Total time of flight. Total time of flight is given by the equation we already derived here. The total time of flight theorem, twice of v naught sine theta over g. Twice of v naught times sine theta over g. Sorry. Now 2 times v naught sine theta. How much? We already calculated here. V naught times sine theta 19.6 meter per second. 90.6 meter per second over g 9.8 meter per second square is almost equal to around 4. It is equal to 4 seconds is the total time of flight. It's simple. Okay, just remember all the formulas that we derived. Good. All right. The third question: how far does the ball travel? You are required how far the ball travel at 4 seconds. See, you are required x is equal to how much? How far? That means in our case, you know, we already calculated the velocity across the horizontal, which is v naught across x is equal to v naught times cos theta, which is equal to 10 meters per second. But it's constant. V naught x is constant. If we take any point, this is v x dy, the horizontal dx v naught x is equal to u v final x, which is the horizontal is constant. That means we have constant until here. Okay, until here we have v final x, which is constant for the horizontal motion. Okay, due to this reason, you know that, look at this equation that we already derived. At any instant time, the value, how far, the value of x is v naught cos theta times t. So in our case, at 4 seconds, at t is equal to 4 seconds, we can calculate the value of x is equal to v naught upon x times t. This implies x is equal to v naught cos theta times t. V naught cos theta we already calculated here. How much? 10 meters per second. It's simple. 10 meters per second. Okay? Because V naught 22, you can use your calculator. V naught 22 meters per second times cos 63. Okay, this gives you around 10 meters per second times the time. The time we already calculated here, okay? 4 seconds, which is around 14 meters. X, the value of x at any instant time. Okay? At this 4 seconds is 14 meters. And that is all we have for today. Yeah, I hope you need some time to practice this question, okay? Especially if you understand the derivation, you can calculate any question, okay? And this is the advanced course for projectile motion. If you have any question, write on the comments. Until then, bye bye everyone, bye bye. Hello online physics students, welcome back again. Last time we have seen case 2 of projectile motion, that is when the object is projected horizontally.